Hi everyone, I am SS Kiran. I would like to discuss introduction about random variables and process. Subject is random variables and stochastic processes. RVSP. Okay, in this subject we cover following topics: set theory, some set operations, a definition of probability, what is sample space, definition of random variables, some classification of random variables like discrete random variable, continuous random variable and mixed random variable. And last two topics: cumulative distribution function, CDF. Okay, the last one, probability density function, PDF. Okay, before going to the topics, general we discuss some introduction about this subject. Okay, now we already now what is random variable, why we study these random variables. Okay, already we discussed subject signals and systems. In that subject we discussed some classification of signals. Generally signals are classified into following types: deterministic, non-deterministic. Okay, these non-deterministic signals is also called random signals. Okay, why these signals are called random signals? Because non-deterministic signals cannot be represented in mathematical form. The pattern of such signal quite irregular. Okay, those patterns are very irregular. That's why these signals cannot be represented in mathematical form. Okay, those signals is nothing but the random signals. Okay, then one more point: the behavior of what we discussed, those random signals, the behavior of which cannot be predicted. Okay, those random signals we cannot be predicted. The behavior of which cannot be predicted, such type of signals are called random signals. Why those signals cannot be predicted? Because of quite irregular. Okay, quite irregular. That's why we cannot predicted such type of signals. Those signals is nothing but the random signals. Okay, these random signals, analyzing and describing of these signals by using some variables. Okay, by using some variables, those variables is called random variables. That's why we study these random variables theory. Okay, the random signals statistically possible and analyze with the help of probability theory. Okay, that's why we also discussed about probability and sample space some points. Because of probability, before we discuss some sample space. Okay, in this way we discussed these random variables because of random signals. Okay, these random signals using some variables, those variables we can call it as a random variables. Okay, now we will enter into the notes. Okay, good. First, set theory. So what is set theory? A set is collection of objects known as elements, like set of aeroplanes, set of chairs, set of capital letters, and elements are denoted by small letters. These are all set. Okay, these set theory, set definition, set operations, countable set, uncountable set, these are all we were studied in lower standards. That's why no need to pay attention now. Just randomly I read some definitions, then you can understand what is needed. In my description I provided my notes link, then simply you can read, you can understand about these basics. Now there is no need to study all the basics and no need to discuss these basics. Okay, a countable set, there is a finite number, there is nothing but a countable. Uncountable means there is not uncountable, those sets are nothing but the uncountable. Empty means there is no elements. Okay, right. Now operations, generally we studied in lower sections: union, intersection, complement, cumulative law, distributive law. Okay, these are all we are already studied. Okay, then associative law, De Morgan's law. Okay, now we will enter into the sample space. What is sample space? The set of all possible outcomes of an experiment, for example, or trial. Experiment or trial. Let us example. Just you can simply toss one coin. There is a probability to show result head or tail. What is sample space? S equal to open flower bracket. One toss is coin, so it has possible to show head and there are other chance to show trial. This is nothing but sample space. You can take 3 coins. There is a set. What is the set space? For 3 H's. HHT. H means head. T means tail. There is a pattern like this. Okay. This is nothing but the sample space. Event also. Okay. Right. Next, there is a different types of events. Null event, elementary event. Okay. I provided the notes. Just you go through it. Right. Then we will enter into the probability. Definition of probability. What is probability? Probability is defined as the study of random experiments. What is experiment? It's a trial. Okay. Probability is defined as the study of random experiments of any random experiment. Random experiments or any random experiment. There is always an uncertainty. Why here called uncertainty? You don't know if you toss the coin, it maybe shows tail, it maybe shows head. That's why it is called uncertainty. So what is the possibility? If you shows tail, there is a possibility 1/2. Okay, we will discuss how it will get 1/2. Okay, right. Now between 0 to 1 is assigned. Okay, probability is 100 when if it is coins having both sides head. If you want head, there is a probability 100% probability, because there is generally you have also observed in IRCT subset also based on this probability confirmation probability. If you click the CNF, we show them percentage. So like this percentage is between 0 to 1. So this is nothing but the probability. Okay, right. What type of probability? Confirmation probability. If there is a chance, if you get the waiting list ticket, there is a chance how much probability it will be get confirmed. Okay, that is the one real time example. Right. Some axioms of probability. I will read only condition, then you can understand. Okay, every probability between 0 to 1. That's why it can write like this: 0 less than or equal to probability of A less than or equal to 1. So coming to null event, pi is null event. So probability of pi is equal to 0. Very important. This probability of pi equal to 0. If it's pi is null event, then the third one, if S is a sample space, this is also very important condition we can use in problems. Probability of S equal to 1. Right, very good. These are all basics. No need to worry about if you cannot understand. Right. Then probability of A bar 1 minus P of A. Then probability of A plus B is equal to probability of A plus probability of B minus probability of A. Okay. These are all some conditions. Okay. A subset of B. Right. Problems. Just you can read, you can observe some problems. A box contains 3 red balls, 4 white balls, 5 black balls, or natural story. Okay, if you want to choose red ball, there is how many red balls? 3 red balls. How many total balls? 12 total balls. Okay, 3 plus 4 plus 7. What is the chance to get red ball? Very simple. 3 red balls, 3 total red balls, 12. That is the answer is 3/12. This is the probability. If you're not getting black, there is a formula. Probability of B bar. Why B bar? Not getting black. So probability of B bar is equal to 1 minus probability of B. Very simple. Probability of B is equal to 5/12. Why? Because black is 5 black balls. Total balls 12. So 5/12. So probability of B bar is equal to 1 minus 5/12 is equal to 7/12. Okay. Just you can see the problems. You can understand. Okay. Right. The next, if you can, all problems are very easy. Simply you can observe, then you can understand. Then we will enter into the concept. Okay, what is conditional probability? Yes, it's a condition. For example, if one event is depend on the second event depends on first event, it's a condition. Okay, consider a box containing red balls and on one white ball. Suppose we draw a ball from the box without replacing the first ball. That is a condition. Without replacing the first ball, we draw a second ball. The probability of getting a red ball in the second draw depends on the outcome. Obviously, second ball if you draw, that is compulsory depend on the draw of the second ball. Okay, these are some theory, nothing to worry. There is a definition like the probability of event B given the event A is known to have occurred, denoted by conditional probability B given A. The formula, probability of B given A equal to B given A equal to probability of A intersection B by probability of A. The condition probability of event A given B is probability of A intersection B by probability of B. Just remember formulas, that's enough. See problems also. Okay, nice. A total probability. What is the formula for total probability? Probability of union n is equal to 1 to n. A intersection B n is equal to sigma n equal to 1 to n probability of A intersection Bn. This is also one more formula for total probability. Just remember these formulas, that's enough. Okay. Now it's a very important topic. Now our core syllabus, right? Random variables. What is random variable? Very simple. Random variable is defined as a real function. As a real function of the elements of a sample space. Random variable is defined as a real function of the elements of sample space S. Random variables are denoted by capital letters. You remember this very valuable point. Random variable denoted by capital letter. In future you won't be never confused. Why? Because random variable denoted by capital letters. Okay, with respect like W comma capital W comma capital X comma or Y, and values of the random variable internally having some values. Those are represented by lowercase letters like A comma B or small w comma small x comma small y. Okay. Now classification of random variables. These random variables classified into three categories. One is discrete random variables, continuous random variables, mixed random variables. We cannot use it that much of mixed random variables. That's why I not mentioned here. Okay, we will study later. Discrete random variable, continuous random variable, and mixed random variables. Now we will enter into the discrete random variable. Yes, a discrete random variable is having only discrete values. The word itself having some definition. What is discrete random variable? It having discrete values. It's having discrete values. It is defined as the random variable which can take only finite number of values. Every discrete random variable can take finite number, very important, finite number of values in the finite observation interval. This means discrete random variable. Simply you can think about one small example. 3 coins are tossed. Okay, how we can define this random variable? So this is sample space. What is the chances? First, if you toss it one time, there is a chance to get 4 heads. Then second one, 2 heads, 1 tail. 1 head, 2 heads, 1 tail. Same phenomena. 1 tail, 2 heads. Okay, one head, 2 tails. This is the way of to represent if we coin to toss. It's like a 0 0 like in STLD 0 0 0 0 1 0 1 0 0 1 0 0 0 1 1 like this. Okay, now in the random variables, the random variable can be can be represent capital X. Okay, the internal values within bracket, that is x1, small x2. Why here I can write 3? Because here I can take what is the probability to get chance head. Okay, how many heads here? 1 2 3. That's why here I can write 3. What about this second variable HHT? That's why here I can write 2. What about here head? There is chance only 1. Here heads 2. Okay, good, right. This is the way of to represent the random variable with values and sample space. Now continuous random variable. In definition itself, there is a reason. A random variable that takes on a infinite number. Coming to discrete, it's a finite, right? It's a finite. Coming to continuous random variable, it's a infinite number of values. We cannot examine like noise signals. We cannot examine of the internal values. Number of values is called the continuous random variable. Example, as already discussed, noise, voltage generator, and electronic amplifier as a continuous amplitude. Okay, these are all the continuous random variables. Now, mixed random variable. A mixed random variable is one for which some of its values are discrete and some of are it continuous. Generally, we can observe in stock market. Sometimes we can observe in the real-time exponential ECG signals. Sometimes it gets some disturbances. Sometimes we get some high peaks, X, Y, Z like this. That is, these variables we can call it as a mixed random variables. A mixed random variable which is having what? Which is having discrete values and at the same time continuous. Okay, we can give some least priority, least important type of random variable. Okay, now probability distribution function, very important. Probability distribution function can be denoted as probability of capital X equal to small x suffix j, okay, is equal to f of x. So f of x is called probability function. No need to put that much of concentration. This is very simple. Probability of capital X is equal to small xj is equal to f of x. F of x is nothing but probability function. This probability function is also called probability distribution function. If there sometimes it asks in GATE examination also, what is probability distribution function? The following options, simply you can write probability of capital X is equal to small xj suffix j is equal to small f of x. Small f of x is denoted as the probability distribution function. Now CDF, cumulative distribution function. The cumulative distribution function of a random variable capital X as the probability that a random variable capital X takes a value less than or equal to x. Here probability x equal to xj. Coming to cumulative distribution function, capital Fx of x is equal to probability x less than or equal to x. Please remember and please understand these two differences. One is probability x is equal to x, small xj is equal to f of x, small f of x. This is nothing but probability distribution function. Here capital Fx of x equal to probability capital X of less than or equal to x. This is cumulative distribution function. Okay, this is very important. Please be concentrate. Now some note, CDF is defined for discrete as well as continuous random variables. Obviously every function can be discussed in the discrete end as well as the continuous. X for event x, capital X less than or equal to small x is also called probability distribution function. Okay, now some properties. Now I will read only conditions, nothing to worry, all the sentence and each and everything. First, every probability with between 0 to 1. That's why why it is called cumulative. That's why here I can prefer capital Fx of x. If it is cumulative distribution function CDF, capital Fx of x only. If it is only probability distribution function, simply we can write f of x. Okay, this with 0 to 1, that's why we can write 0 less than or equal to capital Fx of x less than or equal to 1. The first property. The second property, if x equal to minus infinity, capital Fx of equal to minus infinity equal to 0. If x equal to plus infinity, you can write capital Fx of infinity equal to 1. Okay, then one more condition, if then x1 less than or equal to x2, simply we can write like this, capital Fx of an x1 less than or equal to capital Fx of x2. Why here I mentioned capital Fx, capital Fx? If we get any confusion of this capital and small, very big confusion in the future classes. That's why I mentioned very clearly what is capital X, what is small x. Capital X, capital F, because it is a cumulative distribution function, a small f of x probability distribution function, right? Then if it is fifth condition, fx a probability x1 less than x less than or equal to x2, simply we can write capital Fx of x2 minus fx of x1, right? The sixth condition, fx x plus, there is a condition, initial condition is equal to capital Fx of x, right? Now we will enter into the probability density function. What is before one? Probability cumulative function. Now cumulative distribution function or probability distribution function. Now the next topic is probability density function. There is a very good difference between probability density and probability distribution. Now probability density function can be denoted by small fx of x. Very important. Probability density function can be denoted small fx of x. What about probability distribution function? Distribution function can be denoted capital Fx of x. Now we enter into the definition. Probability density function is defined as very simple derivation of d by dx. What it is called? Derivation of distribution function. Derivation of distribution function. Once again I will repeat you, probability density function is defined as the derivative of distribution function. Now small fx of x is equal to, small fx of x is called density function, derivative of small fx of x, distribution function. Okay, small fx of x is equal to derivative of d by dx of capital Fx of x. For example, if you want a distribution function, how we can write? Simply this derivative which comes to left side, it can be treated as a integral. If you want density function like capital Fx of x equal to, here simply you can write integral Fx of x. I think you know very well. Okay, where Fx of x is the density function of the random variable. I have discussed. Now we will take an example. This is distribution function. Okay, this is the very simple distribution function. Now it will convert into a density function. What is diagram? This is the density function. Okay, this is the distribution function. That's why here I can mention capital Fx of x. Now we can write the density function. This is small fx of x. Okay, next coming to in the discrete random variable, this is the distribution function, this is the density function. Okay, now we will next topic. Okay, some examples. Capital Fx of x is equal to sigma I is equal to 1 to n. Probability of capital X is equal to small xi into u of x minus xi something. Okay, these are all some examples. Just you can read, you can observe, you can understand. This one more equation. Probability of p of xi equal to u of x minus xi. There is a unit step function. Already we discussed in the signals and systems. U of x is equal to 1. This is unity function. If we, if you can do derivative, you get some impulse response. U of x is equal to 1 for x less than greater than or equal to 0. U of x is equal to 0 for x less than or equal to 0. Right? Now what happened? Some existence of probability density function. Just observe only these three equations. That's you can more than enough. Pi of x naught is equal to integral minus infinity to infinity, pi of x is equal to delta of x minus x naught. Okay, if you want derivative of this unit step function, you will get some ramp, you will get unit if you get derivative with the step function, you may get some impulse response, that is called unit impulse, that is called delta of x. Okay, okay, delta of x is equal to d by dx is equal to u of x. U of x is equal to unit step, delta of x is nothing but unit impulse. Okay, this is one way. Then one more, fx of x is equal to sigma I equal to 1 to n p of x is into u of x minus x. This is one more equation. Now some problems. I think you can easily understand the problems. Just you can check. I will explain one problem. A probability density function, the given function small fx of x. I think you can understand. If it is small fx of x, this simply we can call it as a density function. Obviously, you can find the probability function, the distribution function. How we can find? Already I have discussed this problem. This is equation I discussed. Minus infinity to infinity, fx of x is df is equal to 1. Just simply you can write here, take this fx of x, a into e to the power of minus b mod x equal to 1. Then divide partitions, split minus infinity to 0, 0 to infinity, mod x minus infinity to 0, mod x can be treated as a minus x, 0 to infinity, mod x can be treated as a positive x, right? That positive value of x. Then do some integration mathematical part. Finally you get some value. Just I think you people little bit strong in the mathematical calculation. Otherwise just you can read it, it can be understandable. The final answer is equal to b is equal to a. This is the relation of about the problem. Okay, randomly I explain one problem. Then you can see remaining problems, you can understand. Otherwise you can ask in comment sessions, I will explain you. Don't worry. Thank you. Okay, these are all the different types of distribution functions, like probability distribution function, density function, its conversions. Okay, next video I will discuss remaining distribution functions also. Thank you so much. Just you can download notes in my description. I have provided notes link. Thank you so much. Bye.